Okay, so in this our second problem now, we would like to introduce Clinton. Can you please come and solve this problem for the class?
All right. Thank you very much. My name is Clinton P. Kui. Let's look at this question. The question reads, the universal set U, which is 246.25. This is a pattern that the numbers are arranged in. And P, Q, and R are subset of U, meaning they are formed within the universal set, such that P is a set, and that set includes multiples of 3. Q are squares number, and R are numbers whose sum of digits is 8. And we have all of the questions that we are supposed to find given set P, Q, and R from the universal set. So how do we do that? We do this by listing each of the elements of the universal set, set P, set Q, and that of set R. So let's begin. So we write solution. Set U is the universal set, the total set under consideration. And we say set U members or elements are 2, 3, 4 to 25 in this order. So we list them as 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So these are all the elements of the universal set, which is set U. From there, we look at set P, which include multiples of 3. So the universal set is our guideline now. So we are taking all of the multiples of 3 from the universal set. So set P will be equal to, now, the multiples of 3 are 3, 6, 9, 12, 15, that's 18, 21, and 24. So all these numbers are just listed under P as multiples of P. They all divide 3 evenly. So multiple of 3, all these numbers divide 3 evenly. And that's the reason why we call them multiple of P. Let's look at set Q. We say set Q are squares number. So we are going to list the element of set Q up here. Set Q are squares numbers. So let's list all of the squares numbers from the universal set. So we know the first square number is 4, because the square root of 4 is 2. So 4 is a square number, 9 is a square number, 16 is a square number, and 25 is also a square number. So these are all of the square numbers from the universal set. The square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and the square root of 25 is 5. And we have the last set, which is set R. Set R contains numbers whose sum of digits is 8. So we look within the universal set. What are those numbers in the universal set whose sum of digits is 8? And what do we mean? Let's look at universal set. So the digit of this number is a single digit. One digit is 2, and this digit is not 8. This is not 8, this is not 8, but this digit is 8. So you can write this as 0, 8. When you add the 2 digits, you are going to get 8. So the first number that we are going to include as an element of set R is going to be 8. So 8 is the first element of set R. We come here again and say we have 9, the sum of digits is not 8, 10, 11, 12. If you add 1 plus 2, you get 3 and not 8. So you get 15. 5 plus 1 is 6. That will not give you 8. 6 plus 1 is 7. It's not 8. But 7 plus 1 is 8. So the sum of this digit, 1 and 7, these two digits, their sum is 8. So 17 is the next element. From 17, we go to 18. 8 plus 1 is 9. 9 plus 1 is 10. And so on. So you have 2 plus 4 is 6 and not 8. And 5 plus 2 is 7. So 8 and 17 are the only element of set R. So having listed all of the elements of set R, we can now go to solve each of the questions. The first question is we define P, set P intercept set Q. So the intersection, as have been explained in the lecture, has to do with the elements that are contained in both set P and set Q. So A, P intercept Q. Elements that are contained in both P and Q. So there's P, and this is Q. So what are elements in P that are also in Q? We have 9. So 9 is there. 16, 25 is not there. So we have only 9. So 9 is the only element that is found in both set P and set Q. So there's the answer for the first question, the P intercept Q. We go to P intercept Q complement. B, we have P intercept Q complement. So since we are discussing complement, let's list all of the complements of each of the individual sets we're given. So the first set P. What are the complements of set P? P complement are all of the elements in the universal set that are not in set P. So what are elements in the universal set that are not in set P? The first element is 2. 2 is in the universal set and not in set P. 3 is in the universal set. 2 is also in set P. So it's not going to form part of the complement. 4. 4 is in the universal set and 4 is not in set P. 5. 5 is in the universal set and 5 is not in set P. Look at 6. 6 is in the universal set and 6 is also in set P. So it's not part of the complement. 7 is going to form part of the complement. 8. We see 9 in both the universal set and P, so it's not part of the complement. 10. 11. Seeing 12 in both, 12 is here and 12 is there, so it's not part of the complement. 13, 14, and we just list them. 15 is here and 15 is there, so 16, 17, 18 is in both the universal and P, so 19, 20, 21 is in both, 22, 23, and 25. So these are the elements of P complement. Elements that are found in the universal set and not in set P. The next set is set Q. What are the elements of Q complement? Elements that are in the universal set and are not found in set Q. So the set Q are square numbers. So we have 2, 3. We're not going to list 4 because 4 is in set Q. 5, 6, 7, 8, 9 is here, 10, 11, 12, 13, 14, 15, 16 is here, 17, 18, 19, 20, 21, 22, 23, and 24. So these are the elements of set Q complement. Elements that are found within the universal set and are not found within set Q. Let's look at our complement. Our complement, so I want to contain 2 elements, 8 and 17. So I want to list all of the elements of the universal set excluding 8 and 17. So we have 2, 3, 4, 5, 6, 7. Again, 8 is not part of it. We have 9, 10, 11, 12, 13, 14, 15, 16, 17 is now a part. 18, 19, 20, 21, 22, 23, 24, and 25. These are all of the elements in our complement. So, having had P complement, Q complement, our complement, we can now proceed to find P intercept Q complement. So P intercept Q complement has to do with the elements that are found in both P and Q complement. So we have P on the board there, we have Q complement here. So what are the elements that are found in both set P and set Q complement? So we see 3. We see 3. So 3 is a part of their complement. We see 6 and we see 6. 6 is a part. We see 12. We see 9 and 9 is not here. So it's not part of the interception. Not part of the interception because 9 is not here. We see 12 and we see 12. So 12 is part of the interception. We see 15 and 15 is here. So 15 is part of the interception. We are seeing 18. 18 is also here. In set P, we have 21 and 21 is here. So it's part of the interception. And we have 24 and 24. So 24 is part of the intersection. So the intersection of P and Q complement are these elements. And that is question number B. Let's look at C. C says we should find the elements of Q intercept R. So Q intercept R, again, has to do with elements that are shared by both set Q and set R. So here is set Q, here is set R. So what are the elements that are in both set Q and set R? We are seeing that there is no element that is common to these two sets. So Q intercept R is just an empty set. An empty set because there is no element shared by these two sets. We have D. D says we should find P intercept Q complement and R complement. P intercept Q complement or complement. This means what are the elements that are found within a universal set and that is not found within P intercept Q complement. Now we already have P intercept Q complement here, so we don't need to find it again. So what are the elements that are found within a universal set and that are not in this set? Very simple. We can list them. When a universal set has 2 and 2 is not here. So 2 is part of the entire set complement. So 3 is there, so it's not part of their complement. So elements that are found within U, 4 is in U, is not in the universal set. 5 is in a universal set, is not in P intercept Q complement. 5. 6 is here, so it's not part of their complement. 7, 8, 9, 10, 11, 12 is here, so it's not part of the complement. 13, 14, 15 is here, so move on. 16, 17, 18 is here, so move on. 19, 20, 21 is here, 22, 23, 24 is there, and 25. So these are the elements that are within a universal set and are not found in P intercept Q complement, which we already have here. So we'll move on to the next question, question E. And E says, would you find P complement union Q? Now what does this mean? This means that we should list all of the elements that are found within both P complement and Q. We should list all of them within one set, but we should not repeat any element. So what do? We look for P complement. Where is P complement? There is it. And we look for Q. Where is Q? There is Q. So we are going to combine these two elements. We have 2. 4 is here, 4 is here. So we are going to list 4 ones. So 4, 5, 7, 8, we have 9, 10, 11, 12, 12 is not here, 13, 14, so 15 is not more than 16, 16 is more than 2, we have 16, we leave it 1, 17, 18 is not there, 19, we have 20, we have 22, we have 23, and we have 25, because 25 is more than set Q has 25 and P complement has 25. Has 25. So these are elements of P complement union Q. We combine the elements in both P complement and Q. We move to the next. We'll move on to the next question, which is F. F says we should find R union Q intercept. All right. Thank you very much. So we have F. F is R union Q intercept. So this is X, and this X should have been P instead of X. So sorry for that mistake. We have R union Q intercept P complement because there is no set X within our subset. So we have, so the solution for that, for F, we have R union Q intercept P complement. So the first thing we need to know are the elements of R union Q. And then we find the intersection of this set with P complement. So we can list the elements of R union Q. What are they? So R, here's R, and Q, here's Q. So the union of these two sets is the combination of the elements in these two sets. So we have 4, we have 8, we have 9, we have 16, we have 17, and we have 25. So this is R union Q. These are elements in R union Q. Intercept P complement. And P complement is just these entire elements, these very long elements. So we have 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19, 20, 22, 23, and 25. So R union Q intercept P complement. So I've already listed R union Q, I've already listed P complement. So what are the elements that are in both this set and this set? We have 4 is here and 4 is here. So 4 is part of their intersection. We have 8 here, and we have 8 here. So 8 is part of the intersection. 9 is here and 9 is not here. 16 is here and 16 is here. So 16 is part of the intersection. We have 17 here and 17 here. 17 is part of the intersection. We have 25 and 25. So the intersection of R union Q and P complement is just these elements formed within this set. And that's how we find the intersection of these two sets. We move on to the next question. Next question says we should find, so there's G. G says we should find P different. So there's P different Q complement. And we say P different Q complement can also be written as P minus Q complement. And it has to do with elements that are formed within P and that are not formed within Q complement. So what are elements in set P and that are not in Q complement? So we have P, the difference of Q complement will be equal to element in set P and that are not formed within Q complement. So we have 3 there and 3 is here. We have 6 and 6 is also here. We have 9, 9 is not here. So 9 is part of this set. Elements that are in P and that are not in Q complement that are not here. So we have 9, 9 is there and 9 is not here. We have 12, 12 is in both. We have 15, 15 is here also. We have 18, 18 is here. We have 21, 21 is here. And we have 24, 24 is here. So the only element that is proving P different from Q complement is 9. So only 9 is in set P and is not in set Q complement. Now we quickly move on to the next question, H, that has to do with Q complement, the symmetric difference of P. All right, so for question H says we find Q complement, the symmetric difference of P. So within the lecture, you understand the definition of the symmetric difference between two sets. The definition is the symmetric difference. So A, the symmetric difference of B is just A minus B union B minus A. This means you are finding element that is in set A and not in set B union element in set B that is not in set A. So for these two variables, A complement and P, we have Q complement minus P union P minus Q complement. So we are saying the elements that are in set Q complement that are in set P, you know the element that is in set P and not in set Q complement. So let's get that done. So what are elements that are in Q complement and that are not in P? Let's look at it. Is Q complement. Q complement is here. What are elements here that are not also in P? Let's list them quickly. We have 2. 2 is in Q complement is not in set P. So we have 2. We have 3 is in volume. We have 5. 5 is here. We have 6. 6 is in both. 6 is in set Q complement, also in set P. We have 7. We have 8. 9 is in. 9 is not here and 9 is not here. But we are talking about elements that are in Q complement and not in P. So we have 10. 10 is not in P. So we have 10 in part of this element. We have 11. 12 is here and 12 is here. So we have the next 13 is not here. We have 14 is not there. We have 15. 15 is there. 15 is here. The next number is 17. It's not there. We have 18 is here. The next is 19. It's not there. We have 20. 20 is here and 20 is not here. So 20 is part. We have 21. 21 is here. The next is 22. 22 is not here. So 22 is part. And 23. So this set, which is Q complement minus P, intersect with this set P minus Q complement. What are elements in P that are not in Q complement? The elements that are found within P and that are not found within Q complement. I think we've already solved this. P minus Q complement is already here. So since we have P minus Q complement, we just need the element as 9. 9. So Q complement is the symmetric difference of P. We give us the union of these two sets. So all we need to do is just include 9 within this set, and that will be the union. So we have 2, we have 5, 7, 8, and we include 9, 10, 11, 13, 14, 17, 19, 20, 22, and 23. So these are elements that are part of Q complement the symmetric difference of P. And the next question says, will you find Q cross R? Finding the cross product of these two sets. Find the cross product of these two sets. So let's go to. So we have I. I says we find Q cross R. So the cross product of set Q and set R is an ordered pair of numbers. So we group the elements of set Q and set R in an order pair. So where is set Q? Here is set Q. And where is set R? Here is set R. So the first element in the order pair will be an element of set Q, and the second will be an element of set R. So the cross product between these two sets will be 4, 8. So we have 4, 8. And the next element within these two sets is going to be the same 4, 17. So it's 4, 17. So I go to 4. We pair 4 with each of the elements in set R. And then move to the next element, 9. So 9 is going to be paired with 8. And then the same 9 is going to be paired with 17. And then we'll move on. 16 is going to be paired with 8. So it's 16 and 8. And then 16 is also going to be paired with 17. 16 is going to be paired with 17. The next is 25. 25 is going to be paired with 8. And then the same 25 is going to be paired with 17. So we are done with the cross product between these two sets. And again, the cross product is just an order pair of the first set and the second set. The next question is to find, so it is J. And J says we should find P minus Q complement. So P minus Q complement has to do with elements that are found within P and that are not found within Q complement. So let's look at that. What are elements that are found within P and that are not also found within Q complement? So here is a P, and here is set Q complement. So we have, let's see, this question is to find P minus Q complement. But then in one of our questions I was solving, we found the value of P minus Q complement to be 9, if you can recall. So since we already have P minus Q complement as 9, we can just write 9 as the element of P minus Q complement, which is 9, from up there, as we explained. So the next question is K. K says we should find the number of elements in P cross R. The number of elements in P cross R. We are going to distribute this n to each of these sets. So this will be the number of elements in P multiplied by the number of elements in R. And we can see what happens next. So what are the number of elements in P? There is a P. The P has 1, 2, 3, 4, 5, 6, 7, 8 elements. 8 multiplied by what are the number of elements in R? R has 1, 2 elements. 2. So the number of elements in P cross R will be 8 times 2, which is 16. So there are 16 elements in P cross R. So you can do the cross product as we did here and then find the number of elements in them. But this is a very short way of finding the number of elements in the cross product of two sets. We move to the next question. The next question says we should find, so this is K, that is L. Letter L says we should find the number of elements in R, the symmetric difference of Q complement. Now, before we accomplish this, we first need to know the elements in, so we need to know the set that compose of R, the symmetric difference of Q complement. And let's find out first, we'll find the number of elements in that. So R, the symmetric difference of Q complement, that's equal to R minus Q complement union Q complement minus R. This means elements that are found within R and that are not found within Q complement, and we put them together with elements that are found within Q complement and that are found within R. So we have R, the symmetric difference of Q complement, will be equal to. Now, what are the elements that are found within R and that are not found within Q complement? So R only has two elements, 8 and 17, and Q complement has all of these elements. So we check if 8 is formed within Q complement. Yes, 8 is here. And 17 is also here. So there is no element that is formed within R and that is not formed within Q complement. So this is just an empty set. Union. What are elements that are formed within Q complement and that are formed within R? So note, since our other two elements, we take these two elements from set Q complement, and then we list the remaining elements that will form part of Q complement minus R. So it's from 2 to 24. We have 2, 3, 5, 6, 7, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, and 24. So if we find the intersection of any set, union any set, it's just that particular set. So R is symmetric of Q complement is just equal to this set. 2, 3, 5, 6, 7, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, and 24. So this is R is symmetric difference of Q complement. Now, how do we find the number of elements in this? Which is a question actually asked for. So L says the number of elements in R is symmetric difference of Q complement. Why is it? Just count the total number of elements in here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 elements in R, the symmetric difference of Q complement. And we move on to letter M. Letter M. Letter M says we should find the number of elements in P minus Q. So P minus Q are the elements that are formed within P and that are not formed within Q. So what are elements formed in P that are not formed within Q? P and Q. So all of the elements are, so 3 is in P. So 3 form part of it. 3. And then 6 is in P. And it's not in Q. So notice that 9 is here, 9 is here, so it doesn't form part of the difference. 12 is in P and is not in Q. 15 is in P and is not in Q. 18 is in P and is not also in Q. 21 is in P and is not in Q. And 24. So what are the number of elements in this set? So the number of elements in P minus Q now is just going to be 1, 2, 3, 4, 5, 6, 7. 7 elements. So there are 7 elements formed within P minus Q. And the last and final question says we find the number of elements in R complement cross P complement. So the last and final question says we should find the number of elements. So letter N says we find the number of elements in R complement cross P complement. Again, to find the number of elements in this set, we simply distribute the number on each of the set. So this will be equal to the number of elements in R complement multiplied by the number of elements in P complement. So the number of elements in R complement plus P complement is here. What are the number of elements in R complement? So R complement has these number of elements. We have 1 is R complement, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have 22 elements in R complement. Is 22 multiplied by. And how many elements are there in P complement? How is P complement? P complement is right here. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 elements in P complement. 16. So if you multiply 22 by 16, what will you have? See, 6 times 2 is 12. Well, 2 carry 1. 6 times 2 is 12 again, because this one is 13. 1 times 2 is 2, and 1 times 2 is 2. So if you add, you have 2, you have 5, and you have 3. So it's 352. So the number of elements in our complement, P complement, is just 352. So this is how we come to the end of this tutorial class.